Lesson 8.3, proving triangle similarity by, this time, side angle side. So this is part 2 of 8.3. All right, so we have side angle side theorem, which says, similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles so the sides, the two sides create the two congruent angles. If those sides are proportional, then the triangles are similar. Okay, very important. This is the one where they try to trick you. So they might give you two congruent angles, but then the sides that are actually proportional are not the ones that create or include those two angles. So please always check that. All right, so first question is triangle ABC similar to triangle FGH. So we have GFH, 53 degrees, 6 feet, 10 feet, and then we have ABC, ABC. This is 53 degrees. This is 15 feet. This is 9 feet. Okay, so first of all, angle F is congruent to angle A. Okay, and then we're going to look at this. We're going to check the sides that include these two angles. Oops. All right, so the shorter side is going to be FG2AB, which is 6 to 9, which is 2 to 3. And the longer side is FH to AC, 10 to 15, also 2 to 3. Okay, why don't we have to do the third side? Because we already have the angle that's included, right? So you don't have to prove the third side, and we don't even have it in this case anyways. So in this case, so yes, triangle ABC is similar to triangle FGH. And that's by side angle side similarity theorem. Okay. All right, I want you guys to leave half a page. We're gonna tape page 695 concept summary here. Okay, so leave room for that, and I'm gonna have you try is triangle XZW, similar to triangle YZX. Whoops, that's an H. Okay, so for this one, this is more what you're gonna see, to be honest, instead of just two beside each other. So we're gonna draw this, and we have X, W, Z, and Y, 20, 12, 15, 16, 9, and this is a right angle. All right, I want you to try it yourself, okay? So think about what we just did, think about the similarity statement, and then we'll look at it. Okay, so what do we notice? Angle Z is 90 degrees, right? So it is the included angle because it's the only one, XZY and XZW. It's the only one we know for sure is the same. So you have to use it as your included angle. All right, so we're gonna check the sides around it. Okay, shorter side is gonna be XZ, right? If you look at just the left side, the shorter side around this 90-degree angle is gonna be XZ. And if you look at the other one, the shorter side that touches the 90-degree angle is YZ, okay? So we plug in what we know, 12 to 9, which gives us 4 to 3. All right, now let's do the longer side that also touches the angle. So on the left side triangle, the longer side is WZ that touches the 90-degree angle. On the other triangle, the right side triangle, the side is XZ that touches the 90-degree angle or includes it, right? So WZ is 16, XZ is 12, simplifies to 4 to 3. So we can say yes, triangle XZW similar to triangle YZX by side angle side similarity theorem. Okay, now super important on this one that you look at your congruency statement, but also you have to find the angle. If they don't give you, you know, that this angle and this angle are the same, you have to figure out, oh, that's the has to be my included angle, and you have to use then the sides that create or include that angle on both triangles. Okay, short side to short side, long side to long side, check and make sure they make the same proportion.